going to talk through a few solutions for problems on the chapter review. So first of all, if the triangles are congruent, then that means if I'm trying to find x and y, let's find y first. Angle E matches up with angle B. So E and B would be congruent. That means that 6y minus 4 is equal to 80. 6y is equal to 84. And that makes y equal to 14. Okay, and then since I know y is 14, I can make this 3x minus 14. Now segment ED here has to match up with BA. That means that 3x minus 14 would equal 10. 3x is 24, and x is 8. Okay, the next problem that I'm going to go over is the one right below that. It says triangle ABC is isosceles. So I'm going to draw an isosceles appearing triangle here. It says B is the vertex angle, so that means that B is the one that's joining the two legs. Oops, ABC. Okay, AB is 2x plus 15. BC is 5x minus 6. Well, since they're legs, that means that we're going to set them equal to each other. And that means 3x would equal 21, and x would be 7. But then it asked you for the lengths of the triangle's legs. So even though x is 7, we need to plug that back in. So AB is 2 times 7 plus 15, and that's 29. And the other legs should be the same thing because they should be congruent, right? So BC is 5 times 7 minus 6. 35 minus 6 is 29. So they're congruent, as they should be. Okay, on the next problem, this is an exterior angle. Remember that an exterior angle is formed when you take a side of a triangle and stretch it out and use that along with one of the existing sides of the triangle. So the exterior angle equals the sum of the remote interior angles. That means that 2x minus 3 should equal x plus 27. The remote interior means the two that are not touching that angle. So this one right here you don't want to use because that's adjacent to it. It's the other two that are far away from that angle. So 27 plus x is equal to 2x minus 3. That'll give us x equals 30. If you plug that back in, that should work out. You can check it. Okay, on this problem, that is not an exterior angle because it's formed by extending this side of the triangle and extending that side. It's vertical to one of the interior angles. It's not adjacent to it. It's not a linear pair with it. So on this one, we're going to make that 2x minus 1 because vertical angles are congruent. Okay, so then we can just do the triangle angle sum theorem, add them up to 180. So x and 2x minus 1 and 43 adds up to 180. So that's 3x plus 42 equals 180. 3x equals 138. X would be 46. All right, on the second page, this problem up here in the corner. So notice that all the sides are congruent. That means it's equilateral, and therefore it's also equiangular. So remember that for a triangle, equilateral are also equiangular. So if all of the sides are congruent, then all the angles are congruent. And that means each one of them is 60 degrees. So there's 3 different angles there, and it doesn't matter which one you set equal to 60. All of them are equal to 60. So you can add all of them up to 180, or you can make one of them equal to 60 and it should work out. So I think on the answer key, I may have added them all up to 180, but it's a little bit quicker if you just go 21x minus 3 equals 60. Again, all of these would be 60-degree angles. And so 21x equals 63, x equals 3. At the bottom of the page, we're going to kind of work our way around the diagram here. Okay, so the bottom triangle, I'm going to look at this triangle first. The bottom triangle is isosceles, so the base angles are congruent. Okay, then if I do 69 plus 69, that's 138, and 180 minus 138 is 42. So this angle measure up here is 42 degrees. Now that's a right angle, which means this angle is going to be 90 minus 42, which is 48. Okay, and then in this triangle, the base angles here are congruent. So these two have to be the same. So that makes that one 48. And you could do 48 plus x equals 180. Or you can just kind of subtract from 180 to figure that out. 48 times 2 is 96. And that means x needs to be 84. Okay, going to the right of that. We're looking for the measure of this exterior angle out here. So we have an isosceles triangle, so the base angles are congruent. That's 130, which would make this have to be 50. Okay, I'm just doing 180 minus 130. That's 50. And then the vertical angles are congruent, so pull that over there. Okay, and then the base angles on this triangle have to be congruent. And there's two ways you can finish this. You can either figure out that interior angle measure there, which is going to be 80 degrees, right? Because it's 50 plus 50 plus that angle is equal to 180. So that angle would be 180 minus 100 would be 80 degrees. And then this is 180 minus the 80 degrees, so it's 100 degrees. Okay, that's one option. If you notice that you could use the exterior angle theorem here, that'd be quicker. Okay, so if we just thought of this angle right here as being the sum of the two remote interiors, bam, x is 100. Okay, give you the same answer, two different ways of doing it. Okay, for this one over here, let's see, I'm going to go ahead and just pull in that x there has to be congruent to its vertical, so that's also x. And then isosceles triangle, so that's x as well. Let's go up here. Since we know that that angle measures 109, this linear pair right here will be 71 degrees. And I'm going to look at this isosceles triangle up here at the top. So that's 71. So is this one. The other base angle is 71. 71 plus 71, subtract from 180, is going to give us 38 for that angle measure. Okay, and then this one is 90 minus 38, 52. And then x plus 52 equals 180. 2x equals 128. X is 64. Basically, the idea of these problems is you look for isosceles triangles and focus on like one isosceles triangle at a time, right? So you go, okay, I'm going to look at this isosceles triangle. Since those sides are congruent, those base angles are congruent. And then use that to figure out other angle measures. Or it's also helpful to notice that wherever you have an exterior angle or a linear pair, okay, we can figure out this supplement to the angle that we know, and then use that to work our way around the isosceles triangles. For this last problem, I'm noticing that that exterior angle measure is 142. So that means that the interior angle there is 180 minus 142, or 38 degrees. So the vertex angle of this triangle is 48 degrees. I'm actually not going to worry about the rest of that triangle because I'm trying to get over to the other triangle over here. So I'm going to subtract 90 minus 38 to get the 52 degrees. That's this angle measure. Okay, and then that's an isosceles triangle, so the base angles are congruent. That's also 52. And then I can either use the isosceles triangle has two 52-degree angles to find the other vertex angle, or I can use the exterior angle theorem. So exterior angle theorem would go, this angle measure is the sum of the two remote interiors. Okay, and then just do x is equal to 52 plus 52, which is 104. Or I can go ahead and figure out this other angle measure here. So I'm going to call that y. 52 plus 52 plus y is 180. And that's 104 plus y is 180. So y is 76. So if this is 76 degrees, then the linear pair is 180 minus 76, which is 104. So obviously it's quicker to notice that this exterior angle is the sum of the two remote interior, but you'll get there both ways.